rotational equilibrium. A body in rotational equilibrium has no resultant torque. So, kahit anong apply mo na torque, kapag in equilibrium siya, ayan, wala siyang resultant torque. Malalaman natin kung bakit. In such cases, the sum of all torques about any axis must equal to 0. Ayun. So, para masabi mong rotational equilibrium siya, ang resultant torque mo dapat ay 0. Kaya natin nasabing walang resultant torque dahil magiging 0 siya. The axis may be chosen anywhere because the system is not tending to rotate about any point. Ayan. So, ayan. Ang x components niya, 0. Y component, 0. Ito, yan, of all torques, 0 yan. Kapag nag-apply ka. So, paano siya magiging 0? Eh, puro plus siya. Yan. So, kung hindi nyo naisip agad, kung kanina sabi ko, meron tayong counterclockwise at clockwise na convention. So, kung merong isang rotation dyan na clockwise, so magkakaroon siya ng negative. Dahil negative nga kapag clockwise, so magkakaroon ng minus dito. So, kaya pwede applicable na magkaroon ng 0 na resultant torque. So, kunwari, you have here an arm that has a axis of rotation. You applied a force here para mas madali. Ayan, para mas madali, perpendicular agad. Let's say you applied 5 newtons. Let's say ito na yung pinakandulo. So, ito. Pinakandulo na siya. Let's say 2 meters. 2 meters ito. And then ito 1 meter. So, kunwari ito ay nasa rotational equilibrium. So, kung nasa rotational equilibrium siya, dapat ang resultant torques niya ay 0. So, nakalimutan ko sabihin, ang force niya dito ay nandito. And then, hindi natin alam yung value niya. So, paano natin malalaman yung value? So, ilagay natin yung torques. So, ito, dahil perpendicular siya, multiply lang siya. 5 times 1, we have 5 Nm. Huwag na natin ilagay. Plus X Nm. Dahil 1 meter to, diretso na natin. So, Nm dapat yan. So, what is X? Yan. So, if you find X, simple algebra, lipat lang natin sa kabila yung 5 or dahil mali pala yun, add both sides by negative 5. So, maka-cancel to pag nagdagdag tayo. So, matitira ang X, we isolated X, and then we have negative 5 newtons. So, dahil negative 5 siya, tama lang yung drawing natin ng force vector pababa. So, kung pababa yan, pa-clockwise siya. So, kung pa-clockwise siya, negative talaga siya. So, tama lahat ng ating mga signs. Ito, kunwari hindi mo alam kung anong signs niya, alam mong ang ikot niya ay pa-counterclockwise. So, ang mangyayari, positive agad siya, matik na yun. So, ayan, delete natin para sa problem-solving strategy. For the problem-solving strategy, again, label, sketch, free body, diagram, pili ka ng axis of rotation at the point where the least information is given. For example, at the point of application of an unknown force. Sum of the torques due to each force about the chosen axis of rotation and set the result to equal to 0. Ayun yung ginawa natin kanina. Apply the first condition for equilibrium to obtain two additional equations. So, kaya nyo na mag-figure out nyan kung bakit. Basta 0 kapag in equilibrium siya.
In the figure, a non-uniform bar is suspended at rest in a horizontal position by two massless cords, as shown in the figure below. One cord makes the angle theta is equals to 36.9 degrees with the vertical, while the other makes the angle with the vertical, while the other makes the angle phi is equals to 53.1 degrees with the vertical. If the length L of the bar is 6.1 meters, compute the distance x from the left end of the bar to its center of mass. So hinahanap natin dito is yung distance x from the left end of the bar. So ito yon yung edge or yung left edge ng bar natin papunta doon sa center of mass, which is right here, yung nasa yung meron tuldok na puti na yon. So hindi siya necessarily nasa center. Sometimes an ambiguous designation. Kumbaga depende doon sa figure. So hindi porket nasa gitna yun na agad yung center of mass. And this is given by the fact that the bar is non-uniform. So kaya this just adds that your bar can have center of mass na wala doon sa center. So again, this is our figure. So mag-draw muna tayo ngayon ng mga forces na nag-act doon sa angle natin. So una, drawing muna natin yung components of force x. So summation of fx is equals to 0. Bakit siya 0? Kasi it is in equilibrium. So kaya siya 0. So ayan. So our formula or our equation for the summation of fx will be T2 sine phi minus T1 sine theta equals 0. Ayan. So, saan nanggaling yan? So, nanggaling yung T2 sine theta na to dito sa may edges noong bar. So, makikita natin, so if we draw a Cartesian plane here between the edges, ayan. So, makikita natin yung sine phi or yung tension 2. So, ito yon. So ito yung T2, di ba? So, T2. And this is your T1. So, yung T2 sine phi, ayan. So, makikita natin yung tension niya going to the right. So, ibig sabihin, ang sign convention natin lagi na kapag right, it is always positive. So, kaya positive si T2 sine phi. And yung sine theta naman natin is papunta sa left. So, ito yan. So, sine theta. Since papunta siya sa left, we assign T1 sine theta as negative. So, yan. So, that is for our summation of fx. So, for our summation of fy, again, this is also equal to 0 since it is in equilibrium. So, dito naman, T2 cosine theta, cosine phi minus T2 minus T1 cosine theta. So bakit ulit negative? Kasi yung cosine theta naman natin dito is makikita natin dito T1 cosine theta. And dito naman yung T2 cosine phi. So makikita natin yung kapag kasi halimbawa pinutol natin yung cable from either side, for example, pinutol natin yung part na to, yung right side, makikita natin that the bar will rotate counterclockwise. So kapag nagro-rotate ng counterclockwise, if you recall our angular sign conventions, so kapag counterclockwise, we assign it with a positive value. So on the other hand, kapag naman ginupit natin yung cable dito sa left side ng theta, So, the bar will rotate clockwise naman. And since it will rotate clockwise, we therefore assign the left side or the side with theta a negative kasi clockwise siya. So madaling sabi, yung T2 cosine phi, it rotates counterclockwise kaya siya positive, and yung T1 cosine theta naman kaya siya negative because it rotates clockwise. So yun. So yung dalawang formula na to magiging useful sa atin siya mamaya-maya. So again, susunod na gagawin natin is we find the summation of torque on the left side. So T or tau left. So again, since hindi naman siya umiikot, it is resting. So therefore, we write the summation of torque is equal on the left side is equals to 0. So ngayon, ano naman yung mga ilalagay natin dito sa computation natin ng summation of torque on the left side? So, we write T1 cosine theta times 0 meters. So bakit siya 0 meters? T1 cosine theta siya. Dapat may value siya, 'di ba? Kasi yung T1 cosine theta is kasi yung pivot na gagamitin natin is on the left edge or on the edge of the left side of the bar. So yan. So since dito rin located yung T1 cosine theta natin, ibig sabihin walang distance between them. So kaya siya naging 0. So T1 cosine theta times 0. Next, minus weight. Minus weight x. So, ano naman yung weight x na yon? So, from the center of mass, syempre meron din niyang mass meron siyang weight na since hinihila siya ng gravity. So, mg again is also equals to w, which is weight, and yung x naman is your distance from your pivot to your center of mass. So, kaya natin minultiply yung weight by x since it is the distance from your pivot or yung nasa edge to your center of mass. Minus T2 cosine phi times L. So yan. So, tinake into account din natin yung tension naman sa kabilang side. And ang tinake into account din natin dito is yung length noong buong bar, which is 6.1 meters. So yan. So yung L na yan. So from our pivot on the left edge up to the other end of the bar. So that is your L. So yan. So we equate this expression into 0 since it is in equilibrium. And now, we solve for x. Kasi ang nahanap natin dito is the value of x is yung distance from your pivot to your center of mass. So, ang gagawin natin is x is equal to T2 cosine phi L over W. So, saan nanggaling yung expression na to? Simple lang. So, we just manipulated this equation above. So, since eto 0 na siya, so x na yan, so wala na yan. So, we are left with negative wx minus t2 cosine phi L is equals to 0. And then, we just derive it since we are solving for the value of x. So, this will be our working equation when if we want to find the value of x. So, ngayon, ano naman ang gagawin natin? Hindi natin alam yung value ng weight and hindi rin naman natin alam yung value ng T2. Ang alam lang natin is yung value ng L. So, dito papasok yung dalawang equations na ginamit natin kanina is yung summation ng Fx and summation ng Fy. So, we equate the summation of Fx to each other. So, T2 sine phi is equals to T1 sine theta. Ayan. So, since ang hinahanap natin is T1, so we solve this equation in terms of T1 or for T1. So, T1 is equal to T2 sine phi over sine theta. So, ano ngayon yung gagawin natin sa T1 na to? So, ngayon, yung T1 na to, isa-substitute naman natin siya ngayon dito sa summation of Fy. So, to find the value of our T2, so what we will do is again we substitute T1 into the summation of Fy. So this will become T2 cosine phi minus, so ano yung value natin ng T1? So that is T2 sine phi over sine theta So, ito yung T1 natin, di ba? So, tas ikakabit natin dito yung cosine theta. Ayan. So, this will be our working equation. And, another thing to add pala, nalimutan ko. So, sa summation of Fy, hindi lang pala T2 cos phi minus T1 cosine theta ang ilalagay natin. I forgot to add na ilalagay din pala natin yung weight. Kasi, makikita natin yung weight is directed downwards. So, minus W is equals to 0. Ayan. So, ayan. So, kailangan nga parang nakalagay din yung weight. So, makikita natin dito. So, continuing. So, T2 cosine phi minus our derived value for T1. So, T2 sine phi over sine theta times cosine theta is equals na ngayon sa W. So, yan. So, nakuha na natin ngayon yung value ng T2 and W. So ngayon, ang gagawin natin is we now find the value of T2 over W. So, yung T2 over W, so pagbabasihan pa rin natin dito is yung formula kanina. So, itong T2 cosine phi minus T2 sine theta over sine phi over sine theta cosine theta. So, i-derive ulit natin siya and we will get this value. So, 1 is equals to cosine phi plus sine phi times cotangent theta. So yan. So mga ano na lang yan. So tawag dito. So this is just basic trigonometric yung mga trigonometric values natin. So i-recall natin yan sa pagde-derive ng values na to. So ngayon nakita na natin yung value nung T sub 2 or nung T2 over W. And since yun yung hinahanap natin dito sa equation na to kanina, we can now proceed on solving for x. Since alam na natin yung value ng T2 over W, alam na rin natin yung value ng cosine phi, and alam na rin natin yung value ng L, we can now proceed on calculating the value of x. So, to find the value of x, so it will be equal to L cosine phi over cosine phi plus sine phi times cotangent theta. Ayan. So, ito na yung magiging working equation natin. And we now substitute our known value. So, this will become 6.1 meters times cosine 53.1 degrees over cosine 53.1 degrees plus sine 53.1 degrees times cotangent 36.9 degrees. So yan, so substitute na lang natin yung values ng L, ng phi, and ng theta. And we solve for this equation and it will give us 2.20 meters.
Okay, next. Center of mass and average of the distant mass factored by their distances from a reference point. Center of mass yan. Next, center of gravity. It is the point through which the resultant weight acts regardless of how the body is oriented. For applications involving torque, the entire weight of the object may be considered as acting at this point. So, sa ating lesson plan, mas nauna yung center of mass kesa sa torque, which is mas okay din kung nauna ang center of mass para mas naintindihan natin yung pinagsasabi natin dun sa moment arm. So, katulad ng sabi ko kanina, if you have here an object, let's say its center of mass can be found here in the middle. If you put a force here, you can rotate this body, especially kapag nakadikit siya sa sahig. Ito, kunwari, ito pako to, tapos ito nakaangat sa sahig, matutulok mo siya. So, or let's say, sadyang mabigat ito, kung itutulak mo siya, maybe, gumanyan siya, or mamove mo siya ng buo, pero nakaslant. Pero, kung drawing ulit tayo, nandito naman yung same pa rin yung center of mass nila. Tinulak mo siya mismo sa pinakang gitna. Ang movement niya ay lahat. Yun yung sinasabi ko kanina, lahat siya. Dahil sa center of mass mo siya tinulak. Kapag dito, may ikot mo naman siya. So, ayun. Center of gravity, katulad dito, nandito yung ma-add up lahat ng mass. Ayan. Ma-add up lahat yan. So, katulad sa GIF, dahil nandito yung center of gravity, that will also act as your axis of rotation. So, ayan, nakadikit si British guy. So, dahil nandun yung axis of rotation, nag-rotate yung dalawa. So, ayan. Ito, stage siya, walang nangyaring displacement. Ito lang dalawa. Nag-rotate siya, yun lang yung displacement niya. Pati ito, gumanon. So, ayun.
Thank you for listening. I hope you learned something today and see you on the next discussion video.